Hello, YouTubers. This is a new series that I'm planning to start talking about how we could solve software problems. Software is known as solutions to real-world problems, but that solution itself is basically a combination of multiple tiny problems that we try to find solutions for. Problems that could make your software doesn't serve its final purpose, which is solving a real world problem. Let's talk a little bit about from my observation, let's talk a little about, what are the most common software problems that I have come across in my career and how we could solve them, how you could detect them, how you could solve them, and how you could tackle them in the best way possible. So there are categories for software problems. There are algorithmic. These are performance issues. Your software is not performing because your code has a problem. There's a readability part. Your code really is really fast and really good, but the problem is it throws people off when they start reading it. When people look at your code, they don't exactly understand, your variable names, why everything is put together in one method instead of being appropriately spread in separate methods that are easy to test, easy to understand, and easy to modify and improve. There's also the usability part. The usability is more concerned about the UI side of software rather than the backend side of the software. Usability is having the sense of understanding how easy you could make your software for people to use. You must have come through your life, you must have come through software that is so terrible, so confusing. One of the most common things in the tech industry is when you try to submit your resume to a company applying for a job, and then the request asks you to fill in the fields that are already provided, that information that is already provided in your resume. That's a terrible experience. The usability goes down to zero, maybe below zero. We will talk about that. There's also the reusability of your software, meaning your software, you package your software in libraries or you have them in classes. Could people, other software engineers, come in and just pick up your library and start using it? Is it easy to be used by something else? Is your code reusable in a way that will save someone time so they don't have to reinvent the wheel? Can they just use your code for another purpose? Is your code is your code purpose agnostic? Like it can be used as a tool for different purposes. There's also architecture problems, and this is one of the most dangerous things because design problems cost a lot. When you draw an architecture of, oh, I want this service here and I want this database here and I want a time-driven job in here to push data here and there. If your architecture is not set up correctly to solve the problem that you're trying to tackle, the cost could be huge. And we want to talk about how to detect bad architecture, how to avoid falling into a trap when you're trying to design software. You could detect immediately, based on your understanding of the problem, of the real world problem, how I can place my components in my system in a way that will serve my purpose the best way possible. There's also infrastructure problem. Infrastructure problem, you have a built a web app or a service that is very strongly consumes resources on your system, and it can't keep up. There's too many requests coming from the outside world to your service, and your service can't handle that. So that's an infrastructure problem, because your service is not capable enough, doesn't have enough hardware, memory. You don't scale vertically. You don't scale horizontally. You don't scale vertically to to fulfill the amount of requests that are coming to your system. And that's an eternal, forever war between how much cost you're willing to spend on how much hardware. So infrastructure is very focused, on the actual physical resources. Think CPU, think memory, think network connections, security, all that stuff. All of that is encapsulated within the infrastructure. As far as I can tell, I couldn't think of any other common software problem or category that may fall within that list. So I'm going to start with those in this series, and as I go, I hope that maybe if there are any others, I will find them, categorize them, and talk to you about them. Today, though, I want to talk to you about the algorithmic problems in your code. Algorithmic problems meaning you are consuming resources that you really don't need to consume. You're either overly, consuming resources that you could find a way to, like, the whole point of writing good code is to use as little resources as possible to reach to the same goal. So let's take an example of that. I've put together a little code here. Here's an example of something I've seen in real life. I've built this little CRM, and in this CRM I have come across a problem that is very similar to this. What we're dealing with here is you have a bunch of users on your system, and you are trying to calculate the daily activity of every user. This user comes in on the system, oh, they logged this, they sent a message, they did this, they did that. You want to calculate that activity on the system. So one of the things that I've come across, and it was causing a big performance problem, was if you look at the code here, we are grabbing all the users on the system, and then we are creating a list of tuples that will give me the user and how much activity they had, in a particular period of time. The total activities for the user since ever, right? And what I'm doing here is that I'm saying for every user, for each user on the that we have retrieved, so that's n number of users, go ahead and add a tuple to the activities per user list of tuples, where the count, where you add the user, which is the user in the system, and then the count is I go in, I get all the activities from the database, and then I run a query on that, a link expression where I say where the user ID equals this ID, count how much activity this user have done since ever. Here's the problem with that. Every time here I do this, when I make that call, let me simplify the code here a little bit. This call here goes and pulls all the users on the system in the database over and over again. So for every user I am going to consume the database resource, execute a query, and go get all the activities and then filter those activities based on that user. That is a big problem. That will cause, if you have enough users on the system, let's say you have thousands of users on the system, for every user you're hitting the database and pulling all the activities unnecessarily. So this is an algorithmic problem. This is a problem with how you try to minimize the consumption of resources on your system. So how do we fix that problem? I'm just going to copy that guy over. It's very simple. I'm going to call this the good calculate user activities. Instead of trying to call the database every time for each user, we can take that guy out in a list. And then after we made that one call to the database, we just consume what we already have in memory. So this way, instead of me calling the database, if you have 1,000 users here, then I'm calling the database 1,000 times. So n by 1,000 times, regardless of how many activities you have. Instead of doing that, I'm just calling the database one time and then reusing these values that I have already retrieved once. There are really two really good benefits from that. First of all, your application will be amazingly faster. Of course, it will be amazingly faster because you're not paying the cost of recalling the database over and over again. The other thing is, if new activities are coming to the database, then by the time you reach to the 1,000 user, you're not giving accurate data based on the time that you have retrieved those activities in. So let's say at minute 1, you have already calculated the activities for user 1, but by minute 2, you're calculating for user 90, user 1 added new activities. So now the results that you're spitting out is not super accurate for any of these users. So that's another problem. So this is here your algorithmic example. The point here is to pinpoint where you're trying to consume resources and try to minimize that as little as possible. There's a little warning here. You could get too much caught on optimization. You could spend days and days and days when the current performance is legit. It's pretty good. The user is happy with it. So you have to have this discipline, self-discipline, into knowing when to stop. Instead of going because for some developers it becomes an enjoyable activity to try to be as fast as possible. But is it worth the time and the cost? That's the question. So the idea here is, in order for you to solve any algorithmic problem, when you're writing your software, remember first, you could write in a draft solution that consumes resources like crazy, but then try to optimize that as minimum as possible, as long as to the point where it meets your expectation. That's it. So look at this example here, and there are so many other problems that you may come across. Sometimes, for example, sometimes saving all activities in memory is not good enough. Your memory can't handle that data. What if you have here, 200 billion? 200 billion records. That could be a problem. So now you're going to have to think of a solution where you don't have to retrieve those 200 billion. An example would be, instead of retrieving the 200 billion, you only hit the database for the portion of data that you need. And I know that might sound contradictory to what I said earlier, where you just save all the data and then start querying it. But if your memory can't handle that, then maybe at some point you want to say, get all activities from database for this particular user, and then execute the query on the database. So that now becomes a better solution than saving all the data on your memory. So you see, you have disk consumption, that's the database, and then you have memory consumption. And then on top of that, you have CPU consumption. These are the three things you want to look at in addition to the network when it comes to trying to have your code as optimum as possible. The network part I didn't talk about because it is strongly related to infrastructure problems. What is the infrastructure problem that may have you wanting to rethink, making calls through the network and grabbing data over the wire? We will talk about that in the next video. Thank you for watching.